All right, so in number 1, I saw a couple people do this and I think it's brilliant. So if you make an X on all of the obtuse angles and an O at all of the acute angles, O equals O, the acute angles are all going to equal each other and the obtuse angles are all going to equal each other. And an acute plus an obtuse is going to equal 180. So supplementary means 180. So we want something that is not this, right? We want something that is not that. So 1 and 6, 1 and 6, that is acute and obtuse. So that one's going to work. And then 3 and 8, 3 and 8, that's an acute and an obtuse. So that's not going to work. 2 and 7 are 2 acute angles. So those should equal each other. Those are not going to be supplementary. I don't know if that helps, but I like it when I see it, when I see students do it. 4 is obtuse and 6 is acute. So those are going to be 1 of each, and those are going to add up to 180. Does that make sense? Anybody? Lots of ways to look at that. That's just one. Michael and Theodora, we are in the warm-up, the link. Let's see if I can add it again. The link should be in the chat box right about now. There we go. For number 2, you need to find the slope, right? So when you found the slope, what did you find? Anybody find the slope? I know a couple people did. It is 1 over 2, and it's 1 over -2 because we went to the left, right? So -1 over 2. So you just apply that slope because we want a parallel line. So up 1, left 2, up 1, left 2, up 1, left 2. And any of those points would work. Well, not that last one that I did, but we want this line right here. Right? So you find the slope and apply the slope. A lot of students think this kind of problem is really hard. You guys knocked it out of the park. So proud of you guys. This one gets a little crazy. So what I saw that I loved where people went through and they said A, B, D, E, and G, H are all parallel. So A, B, D, E, and G, H are all parallel. And then they went and got another color and they said B, C, E, F, and H, J are all parallel. So B, C, E, F, and H, J are all parallel. Then I've got one more set of parallel lines, I think. 1, 2, 3. So 1, 2, 3, oh, and 4, right? So if I know that this angle is right, that means all of these are right. And if I know that this one is 115, then this one over here has to be 115. And these, the green and the blue, are going to equal 180. I have one obtuse angle and one acute angle. They're same side interior, so they have to equal 180. So if this guy is 115, then this one has to be 180 minus 115, which is 65, which means this angle up here is also 65. The temptation is to say the answer is 65. We want from C to B to A. So we want this whole thing. What do I have to add to 65 to get my total answer? That 90 degree. So really I need to do the 90 degrees for A, B, E, and then the 65 degrees for C, B, E. And the final answer, I think, is going to be 145. That is definitely an all-in difficult question. Number 4, I think everybody who did this got it right. We've seen 20, 21, and 29 a lot. That should just be part of your brain now. But if we didn't recognize any, we could do a squared plus b squared equals c squared. You just have to read carefully and see that right triangle, right? Questions on that? We're just going through it. All right. Number 5, I'm going to get another color because that green is hurting my eyes. So you got to read here too, equilateral triangle. That means those two things are 14. That means my hypotenuse is 14 because this diagonal is this diagonal, right? And then if it's been folded in half, my x is that vertical piece. That means this is 7. So I've got a leg and a hypotenuse. A squared plus 7 squared equals 14 squared. And when you do all of that, you end up getting 7 on the square root of 3. Did I go too fast? Do we need more explanation on that one? No? Okay. Number 6. How'd you attack number 6? What'd you guys do? Did you eliminate anything that was obviously not right? Did you make a fraction? Did you find a decimal? No? Okay, I'll tell you what I do. I notice what kind of triangle this is. This is an isosceles triangle, right? Because I've got two sides that are the same. So I look over here and I've got two sides that are the same. This one is scalene. I don't have any sides that are the same, so I eliminate C. Then I come over here and I have an isosceles triangle and I have an isosceles triangle. But something looks weird about D. What's weird about D? What's different? This one's short and fat, and this one is tall and skinny, right? So it's not going to be D. Make sense? Are we okay for eliminating C and D? Yeah? Okay. So then I make a ratio, and I always do small over large. You don't have to do it that way. You just have to be consistent in whatever way you do it. So I always do small over large, 4 over 5.5. So what would be my fraction for A? Don't all speak at once. You can put it in the chat as well. If I do small over large, I need... Absolutely. And then for the last one, same thing, 3 over 5.83. Then it's a calculator thing. You just put all of those in the calculator and get a decimal. So if I grab my calculator, it's right here. We're going to do 4 divided by 5.5 and get 0.72 repeating. That's my target. I'm looking for one that matches that. So 3 divided by 4.125 is going to give me my 7.2 repeating, 0.72 repeating. So A is going to be my answer. If I do that last one, just because, you know, I'm not always confident about my calculator work, 0.51 is my decimal here. That is not going to be the right answer. Does that make sense? So you can alleviate some of your stress and some of your work by eliminating the bad choices and then calculate among the good choices. So number 7. I think everybody drew the picture, made me so proud. So we draw the picture. We've got a triangle that's labeled JKL, JKL. Side JK, so there's 2 letters, mean that's a side. Between J and K is 68 centimeters. Between K and L is 62 centimeters, which means if the perimeter is 200, that's the distance all the way around from J to K to L and back is 200. So if I do 200 minus 68 and minus 62, that should give me that last side. So 200 minus 68 minus 62 is 70. So then if this is the largest side, this is the largest angle, right? So greatest angle is L. No, greatest angle is K. Oh, greatest angle is K right there. And then the smallest side is 62. This is the smallest side. So J would have to be the smallest. So no, J should be the least and J should be the least. Does that make sense? Celebrations! Yay! Someday you guys are going to have more energy than me. I don't know what day it's going to be. Maybe the last day of class. But I'm looking forward to that day when it happens. Any questions about the warm-up? Okay. I'm just trying to close out some tabs. I feel like I have a lot of tabs open. So I really am a little worried that I scared everybody off yesterday. Before we go into our groups, before I share too, I saw a couple people did some work yesterday. Because there are only 15 of us, I guess. I am still going to put you in your groups, but do you have any questions before I do that? Concerns, worries, problems?
So, for instance, if I revisit these ones, I just could not get it. Yeah, same.
The struggle was real, huh? Do you want to do one all together right now?
Yeah, that would probably be a lot more helpful.
Let's do that. I'm all about that. Let me find some paper. Does everybody have their paper? So grab your paper. And if you get stuck, turn on your camera and let me see where you're at. Do we want to start with the pentagon, the hexagon, or the octagon? Because we can do any of them or we can do all of them. Hexagon? I think the hexagon is one of the easier ones. So let's start with that. We're going to start with our paper like this, and we're going to fold it in half. You want to make sure that the corners are lined up nice and straight so they all match. So you're creating two new rectangles. And I'm just going to pull up the directions to make sure I don't do anything crazy. There we go. All right. My fold side is here. Okay. My folded side is here. I'm going to fold it down. Boom, like this. Okay. So I've done hamburger and hamburger. Started with a whole piece of paper. Folded it hamburger style. And then folded it hamburger style. If you want to, in that corner that I'm pinching where you've got a fold at the top and a fold on the side, put the letter G right there. We're not going to put all of the letters in there because sometimes I think all of the letters confuse people. We're just going to put the ones that we absolutely need. So put a G right there. And that's where I have a crease at the top and a crease at the bottom, or a crease at the side. Is everybody good with that? Thumbs up? So now we want to fold it one more time. You're going to fold that crease line at the top down to the bottom. So that G that's at the top is going to go down to the bottom. And you want to make sure all your corners line up as perfectly as possible. And now you've got a skinny little rectangle like this. The G that was at the top is now at the bottom. Okay. The next fold is the hardest fold, and I always have to read the directions. Okay. So let me read the directions real fast. Unfold this. Place the lower left corner, EF. So that's the corner under the G. And we're going to put it all the way up to JK. What we're going to do is fold G in half. So we're going to take this folded edge and lay it on top of this folded edge and bisect G. So we're going to fold G in half. Okay. So I've taken this short folded edge and folded it up onto the long folded edge and folded G exactly in half.
Can you repeat that one more time?
Oh no, that's not what we're doing. I just did it wrong. Forget what I just told you. And yes, Michael, I can say that again. But let me say it right this time. I forgot we were making the hexagon. Okay, let me back up. That's why I said I have to read it again. The struggle is real. So instead of folding it exactly in half, we're trying to fold this into thirds. So I want you to take this lower corner, and you're still going to make a point at G, but we're going to fold it so that it's right on top of that line. So I've got a fold line here, and we want to take this lower corner and fold it so it goes up to that line exactly and makes a point up here. So we're not going to fold it exactly in half. We're going to fold it like into thirds is what we're going to end up doing. This corner G, that's 90 degrees, we want it to be 30 degrees and then 60 degrees. So I'm taking this bottom corner and folding it up to that line, that fold line that we made. How's everybody doing with that one? So G is going to be a pointy angle, and we're going to fold it into 30 degrees and 60 degrees. Is everybody there? Yeah? Now we're going to fold this top part backwards along the fold line so that we're folding that 60-degree angle into a 30-degree angle. Okay, so let me go back to where I was. We were at the 90 degrees, right? That's the easy part. Then we're going to take this bottom corner where there's a fold right here, and we're going to put it up on that line that we made, that folded line. And then we're going to take the top part and we're going to fold it backwards like this. If you measure this with your protractor, somewhere I have a protractor. I have too much stuff on my desk. It should be 30 degrees. I can't find my protractor. The struggle is real. Okay. Let me go back one more time because I know some people are still struggling. This bottom corner at the fold edge, you're going to fold that up to this point right here, which is on your horizontal fold, right? And then you're going to take this piece and you're going to fold it down. This should be a 30-degree angle if you measure it. Now, where to cut is sometimes the question. So somewhere you should have a fold line like right here. There should be a flap that comes out. You want to cut along that fold line. So if I grab my scissors, did it work? Anybody brave enough to show me their hexagon? Somebody's brave enough, I know. Yay, it worked. Michael, it looks like you folded it, but not on the fold line. So I'm going to get a new piece of paper. You folded it in half and keep the fold line on your right side. So the fold line is in my right hand. And then fold it down. So you've got the fold line on the right side and the fold line on the top. So fold on the right and fold on the top. And then fold it one more time. The corner where all the folds are up in the upper right-hand corner. And you want to fold the two fold sides down. So the heart of your paper, the center of your paper, is what you're folding. So the center of your paper is right here. So where are your fold lines? Yeah, where you're pinching, that's the corner you're going to fold. So that corner becomes this point. That's the center of your paper. And you want to fold that corner into thirds. So that's perfect. And then that corner where all of the folds are, you're going to take the short side that's underneath that and fold it up to that line, the horizontal line. So you made a horizontal line here. You're going to take this corner and put it right there. And then this point is where all your folds come together. That's the center of your paper. If you have your hexagons, start labeling these. So interior, 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 central. And some of you may not have scissors. If you don't have scissors, you can tear this line and that works just as well. So you just got to be careful when you tear it. So sometimes I draw the lines where I'm going to cut it. And if you don't have scissors, you can just tear on those lines. Just kind of carefully. And then you've got your hexagon. Do you want to do the octagon? And then you can label everything? Or do you want to try the octagon on your own? Okay. Did the hexagon work for you, Elise?
No.
Sweet. Okay. So let me scroll down so I can see the directions for the octagon so I don't mess it up. All right. So we're going to start with another piece of paper and it's going to be vertical. And we're going to fold top down. So we're going to have a crease at the top. Okay, so all I did was I tipped my paper, it was vertical, and I folded it down. Now we're going to fold it in half again. It's just like we did the last one, honestly. So I've got a crease at the side and a crease at the top. And I'm going to label where those two creases come together. I'm going to label that G. Okay, so I started with my rectangle like this, and I folded it down, and then I folded it over. So where those two sides that have creases come together, that's my G. Okay, that's the G, where I've got a crease at the top and a crease at the side. This is the one where we're going to do it like I wanted to do the last one. You're going to fold the two creases on top of each other and bisect G. So this is a 90-degree angle. We're going to fold it into two 45-degree angles. So you're just going to fold that in half and make G a super pointy 45-degree angle. All right, so G was a 90-degree angle. We just folded the two fold sides on top of each other. Right, so my open sides are over here and down here. We want to put the two folds on top of each other. to make G a 45-degree angle. And you can use your protractor to check it. Okay. This is where it's almost like making a paper airplane. If you open up that fold you just made, so G is in the middle, you can fold the right side back. And all you're doing is cutting that 45-degree angle in half. You're kind of bisecting it. And it's almost like making a paper airplane. You want to fold it down so those triangles are exactly the same. They're congruent. Okay? So it's almost like you've made a little paper airplane. Okay? You started with a rectangle, a 90-degree, and you folded it in half to make it 45. And then you folded those two wings down to make them 22 and a half. So you've got kind of a paper airplane. Is that good? One of those wings is short. This short wing right here, that's going to be your cut line. So if you fold everything flat, that short wing is where you're going to cut. So if you open it up and look at your paper airplane like you're going to throw it, right? This is your cut line. So when you fold it all back together, you can mark that is your cut line. And if you don't have any scissors, again, you can just tear it. Just be careful when you tear it. Boom. When you open that guy up, your little paper airplane should become an octagon. And what you want to do again is measure those interior angles. So the interior angles are around the corners, around the edge. And the central angles are in the middle. How do we do on the octagon? Did it work? Anybody want to show me their octagon?
I'm stuck at the folding part.
Which folding part?
Like when you put the angle, I'm at that part.
Okay, so we folded it in half. It's so hard to fold in the air. You really need a table. And then we folded it in half. So you have a rectangle, Michael?
Yeah.
Okay. Pinch the corner where the two folded sides come together. You've got a folded side here and a folded side here. Pinch the heart of your paper. That's the center of the paper. That's the angle you're going to fold in half. Okay. So you're going to take those two folded edges and fold them on top of each other and make that center part of your paper into a pointy 45-degree angle. So that's that center of my paper. However that's oriented. This is where the two fold lines come together, and I've just put those two fold lines on top of each other to make a really sharp, pointy 45-degree angle. Got it? So now it's time to make your paper airplane. These two things are going to become the wings. So you're going to take those fold lines and fold them down to the center. So like the sides of your rectangle are coming down to the center of your paper. And it should kind of make a paper airplane. So again, I went from my 90-degree angle and we folded that in half. And you got to make sure that this corner that you're folding in half, that you're bisecting, is the center of your paper. You've got fold lines on one side and fold lines on the other. You can't open those. So we fold it in half, bisect it, that makes it 45. And then we fold the wings down and that makes it 22 and a half and 22 and a half. So if you use your protractor, this should measure 22 and a half degrees. And then your cut line is that line right there. Yeah, perfect. So one of those wings is shorter than the other, right? That's going to be where you cut. So if you fold your paper airplane back, that fold line right there, and I know it's so hard to see, That fold line right there is where you're going to cut.
So like right here.
Let me see. Yes. The shorter one. So you've got one that comes up and one that's like almost flat. You want to cut at the almost flat one. So again, if you look at your paper airplane, like from the top down, you should have one short wing and one long wing. You want to cut on the short wing. That one right there. And it should be almost flat. Did that work for everybody? Maybe kind of, sort of? So as long as we're here, let's all meet on this assignment. And if you want to go work on something else, you can. But as long as we're here, let's fill out this table. Yeah. It doesn't matter. They should all be the same. So what I'm trying to get at there is that they're all the same. So whatever you measure them, they should measure, because they should, if we folded it perfectly, all the sides should be exactly the same. And I don't know if, oh, there we go. Let's fill in this table together. So for your table, if we're looking at the hexagon, right, all of these interior angles should be really close to 120 degrees. So the interior angles are the ones on the outside, but at the perimeter. And they should be really close to 120 degrees. That's kind of your goal. So if you want to open this day 2 regular Polygon Snowflakes assignment and put in 120s, you should have 120s pretty much all the way through. That's kind of the goal. And then these central angles, oh, I picked up the hexagon, didn't I? 1, 2, 3, 4, 5, 6, 7, 8. I picked up the octagon. These central angles, like the pie pieces, they should equal 60 degrees because all together they're 360 degrees. So 360 divided by 6 is 60. So for your central angles, for the hexagon, those should all be 60 or very close to it. If we folded this correctly and it's regular because it's all the same on all the sides. We're not going to fold exactly right, so it's not going to be perfect, but it should be close. So when you're filling this out, you should have 120s or something close to it all the way across the first row. You should have 60s all the way across the next row. And then this is a really important part. Don't skip this part. The trash that you cut off, that's important. So if we put that back together, oh, don't have my right one. If we put that back together, we can see the exterior angles. And just like on the warm-up where we had interior and exterior angles, acute and obtuse, here we're going to have the same thing. The exterior angle makes a straight line with the interior angle. I don't know if you can see on my screen, but the interior angle and the exterior angle, that piece of trash that you cut off your snowflake, should make a perfectly straight line where the interior and the exterior are the same. You should be able to also take that and it should fit exactly in your central angle. So central angles and exterior angles are always the same. And they're always supplementary to the interior angle. So that's why we've got this 60 and supplementary. Everything in red needs to be on your document. Same thing with the octagon. trying to see who I missed for attendance purposes. There we go. Now I got everybody. So same thing with the octagon. You should have 135, 45, and 45. So if you're not wanting to do the snowflakes, you are 100% welcome to go try to do something else. And I'll take requests. But what I'd like to do now is talk about this table down here. So it might be helpful for you guys to stay and do the table with us. Okay. So everybody meet me on this table, regardless of what you're doing. Let's pause for a second. How many sides are there in a triangle?
3.
3. How many sides in a quadrilateral?
4.
4. Pentagon?
5.
Hexagon?
6.
Nice. Sevenagon? 7. So there is a legit name for a sevenagon, but I always misspell it, so I like to just use sevenagon. How about an octagon? 8. A nineagon? 9. So anything that has a number in front, that's just the number of angles and the number of sides. How about a decagon? 10. So let's go back to our hexagon, because that's the one we were kind of just working on. What was the size of each interior angle of your hexagon? What would we measure that as? We could go back up to our chart. That hexagon had an interior angle of 120. So we can find that by doing the number of sides minus 2 times 180. So stick with me for a minute because this is the hardest one. 6 minus 2 is 4. 4 times 180 is what? Anybody? 4 times 180?
Is it 720?
It is 720, absolutely. So if I added up all of the interior angles in any hexagon, it would equal 720 degrees. All of mine are the same, so they're all 120 because 720 divided by 6 is 120. What was each exterior angle? So if I put my trash paper back on top of it, what was the exterior angle? I know the inside is 120, then the outside has to equal 60 because 120 plus 60 equals 180, right? They're supplementary. The other way to calculate that is 360 divided by the number of sides. So there's 360, think circle, right? This, if we had enough sides, would make a circle. So 360 divided by the number of sides always gives you that exterior angle. The total exterior angles is always 360. And the central angle is always the same as the exterior angle because, again, the central angles make up 360 degrees. They make up a full circle. So those should be 60 as well. Let's see what else we can fill in. Where do we want to go now on our little table here? Would it be easy to do all of the central angles?
Yes.
What would be the central angle for a triangle? What math would I do? If I know there's 3 sides.
Would it be 120?
It would be 120. How'd you get 120?
Because you did a 360 and you divided, but I just divided it out 3 and I got 120.
Bam, done. What about the central angle for a quadrilateral? What math would we do there? Maybe somebody else. If I have 4 sides and I know I need to do 360 divided by the number of sides, what would that be? What's 360 divided by 4?
90.
90, yeah. What about the central angle for a pentagon? So we didn't do the pentagon this morning, but the central angle of a pentagon is 360 divided by 1, 2, 3, 4, 5, which is, it's going to be our first decimal, I think.
72.
Oh, no, it's not the first decimal yet. That's the 7. So then we already did the hexagon. What's 360 divided by 7? So if I had a 7agon, what would each piece be?
51.4.
51.4. Nice. What about the octagon? We have an octagon. What's the central angle of that octagon? 45. And that was our fold right here. That's an 1/8 of a octagon. What would I do for a nonagon? What math do I need to do?
360 divided by 9.
Boom. What is that? 360 divided by 9?
40.
Mm-hmm. And last one.
360 divided by 10.
Yes, ma'am. So if I know all my central angles, what's exactly the same as the central angles? The, out here, what do I call that? Not the interior, but the exterior angle. Yeah. So can I just copy this entire row and move it up here? Yeah, it's the exact same formula. The interior or the exterior angle and the central angles are all going to be exactly the same. Okay. And the total exterior angle is always going to be 360. So ladies and gentlemen, the exterior angles and the central angles, wicked easy to find. Okay. It's these interior angles that cause a lot of heartache, right? Because these weird formulas, n minus 2 times 180, just seems like a lot of work until you've done it a half a dozen times, and then you just resign yourself to n minus 2 times 180. So everybody say that with me out loud inside your house. You don't have to have your mic on, but just say n minus 2 times 180 interior angles. N minus 2 times 180 interior angles. If we were in class, we would be chanting this, right? So what math do I need to do for interior angles for a triangle? N minus 2 times 180. So 3 minus 2 is 1, and 1 times 180 is 180. We know this to be true. Triangle sum, every single triangle, regardless of how you draw it, the angles have to add up to 180 degrees, right? Hopefully you're saying right, and I just can't hear you. What's the total interior angles for every single quadrilateral? If I measure the angles in my calculator, what are they all going to add up to? 360. Every single quadrilateral that you could possibly ever draw. If the shape has 4 sides, then all 4 of its angles are going to add up to 180 degrees. How do we figure out for a pentagon? We've got our pentagons. This is the hardest one to do, by the way. So how do I find out the interior angle? I don't want to do origami. I don't want to cut it. I don't want to measure it with a protractor. We can use our formula. 5 minus 2 times 180. And what is 5 minus 2 times 180? Do I sound like a machine? Like a robot?
Yeah.
Sometimes that happens. I don't know why that happens. I think it's my internet. It's not telling me I have an unstable connection, but it really weird students out. I'm sorry. What's the interior, the total interior for a pentagon? 5. And for a hexagon? Yeah. An 8-sided shape of octagon. Mm-hmm. Last two, ladies and gentlemen. Nice. If you think about it, if the total, right, is 1440, and it's divided among 10 equal corners, what's 1440 divided by 10? 1440 divided by 10. Regular shape. You can find the total and then divide by the number of angles. Because they're all going to be the same. It only works if it's regular. So what would be the regulars? Each angle for a hexagon. What goes here? 1260 divided by 9. Mm-hmm.
Would it be a decimal?
It is going to be a decimal, and it's going to be the supplement to this 51.4. So these two columns or these two rows should add up to 180 every time. So what's that one going to be?
128.2.
Perfect. So this row here and this row here are going to always add up to 180 degrees. So the yellow plus the blue will always be 180. How would I get number 5 or a 5-sided shape?
$72.
72 is the exterior. What's the interior? So we can either do 540 divided by 5 or 180 minus 72. 540 divided by 5 or 180 minus 72. Feel free to put it in the chat. $540 divided by 5 or 180 minus 72. So this is our pentagon. What's each of the interior angles of our pentagon?
It would be 108 again.
It would be 108, absolutely. What about a quadrilateral? I have an interior angle of 90, then my exterior angle is going to be 90, right?
So would it be 9 again? If we use 360 divided by 4?
Absolutely, yep. And then what about the triangle? If I have an equilateral triangle, what's the measure of each inside angle?
60.
You got it. So I would love for you guys to cut those snowflakes. They get really pretty and they show you all kinds of great lines of symmetry where you can fold them. Like that's my octagon. because I can fold it down to 90 degrees and then 45 degrees and then 22.5 degrees, right? Once you get over the folding part of it, they're kind of fun to do. But it is these angle measures that's most important. So my question to you at this point is this. We've got like 20, 25 more minutes of class. Do you want to continue working whole group together, or do you want to go into your breakout rooms? I'm happy to do either. Whole group? Okay. Then you guys drive the bus. If I go back to the assignment here, maybe. I also put in a new resource last night into the folder. You now have a digital notebook here. So your digital notebook has all kinds of extra videos and stuff to help. Okay, so definitely use this. We just did this chart. So if you didn't understand what we just did, you can watch this video and fill in the chart here, and that'll help. What I'd like to do, if this would respond, I think my internet is seriously unstable. Do I still sound like a robot?
No.
Okay, good. This is the explanation for the interior angles. I think if you make those snowflakes and label the interior angles, you're going to get this really fast. So I don't know that we need to go through all of this, but I did want you to see that it was here. Okay, so hopefully a lot of you are referencing those digital notebooks. We just did the polygon snowflakes. Do you want to do the polygon pear deck?
Yeah.
All right, let's do it. And then I think you'll be ready to do homework 1 tonight. So if I did my job right, you should be able to click on this link, right? And go to this. Or you can click on the polygons and it should take you there. If you struggle with this and you don't understand what we're doing, go reference pages 3 through 8 in the digital notebook. Okay, it's there for you. I am going to jump over here to look at it so that I can write on the slides. Did the link work? Can you get into the pear deck, or do I need to put the link in there in the chat? Okay. Maybe. Did the link work? Some of you have already opened it, I think. So this might be a review for some of the people that I worked with yesterday. Are we all on the same page, the red slide? Hopefully. What kind of shape should I draw here if I have vertices A, B, C, D, E? A, B, C, D, E. How many angles is that?
5.
5. So if I have a 5-angled shape, how many sides does that have? If I have 5 angles and I have a side across from every angle, should I have 5 sides? So I could draw myself a pentagon. Doesn't have to be perfect. A, B, C, D, and E. Okay, so I've drawn an image. I have 5 sides and 5 angles because I've got 5 here. So if I want the interior angle sum, what equation do I have to use for my table that we just did? The total angles in a pentagon. You have your snowflake. How do I get the total angles? Something with a 180. What do I have to do with the 180? We chanted it. N minus 2. What's my N? 5. Absolutely. So my N is 5. That's the number of sides. So in the calculator, N minus 2 times 180 is what? Mm-hmm. 3 times 180, which is what? 540. You got it. So interior angle sum, always N minus 2 times 180. Okay, that's going to give you the sum. So for number 3, or slide 3, number 2, are we still looking for the sum, or are we looking for something different? We're just looking for one interior angle here. So we want the measure of ABC. That's just one of those angles. So we've got to take that a step further. Instead of just N minus 2 times 180, we've got to find each of them. So then we've got to divide by the number of angles, right? So we'll find the total for the whole shape and then divide them equally among all the angles. But first step, we need to know what the N is. How do I figure out what the N is? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Fantastic, Michael. So then all I'm going to do is I'm going to substitute that 10 in everywhere I see an N, and then put that in my calculator. So 10 minus 2 is going to be 8. So 8 times 180 divided by 10. How big is that angle be? And hopefully everybody's pulled out a calculator and is doing that. Perfect, 144. It's also in your table, so you can just look it up in the table if you want. I like calculating it. But are we good with questions 1 and questions 2? I'm looking at the chat. I'm not seeing any questions. You guys got to talk to me and let me know if I'm going too fast, too slow to fill in the blank, right? So the yellow slide, slide 3, given quadrilateral KLMN, what is the value of X? So what do I know about the total interior angles of every quadrilateral? So I've got some steps down here. What do I know about every single quadrilateral ever known to man? All the angles add up to? That's your cue. What do all the angles in a rectangle add up to be? All the angles in a square add up to be? $360, right? So quadrilaterals are always 360 degrees. N minus 2 times 180. So N minus 2 times 180. If we're not sure, we can do that. So that would be 4 minus 2 times 180, which would give me 360. So if I know all of those angles are going to add up to 360, what equation can I write? Can I just... How did I know what? So interior angles are always this formula. And that's in the chart. So if I go back to the chart real fast, interior angles, always this formula. So if I want the total interior angles, N minus 2 times 180. If I want each interior angle, N minus 2 times 180 divided by N. Those are just formulas you've got to memorize. It's kind of like slope, distance, and midpoint. They're not on the formula sheet. That's why I haven't given you a formula sheet yet. You just got to memorize them. It's kind of stinky. But I do know that every quadrilateral is 360, just like every triangle is 180, right? So once I write my formula, and that is a great question, how do you know? Because sometimes you just know and you don't know how you know. I've got to combine all those like terms, right? So if I combine 3x and 1x, how many x's are there? Mm-hmm. And if I combine 25, 95, and 80, what do I get? We're almost there, guys. 200. Excellent. And then we're just going to solve that equation. I'm going to get my x's by themselves. So I'm going to subtract 200. So I get 4x equals 160. And then divide by 4 and divide by 4. And 160 divided by 4 is 40. And that is my final answer. If they asked for what is like angle L, then you'd have to substitute the 40 back in. But because they're just asking for x, we done. We ready to go to the green slide? I know I can write faster. I can slow down. Yes, ma'am. Guys, let me know when we're ready to go to the green. And on every one of these slides, those steps underneath are designed to kind of help you, figure out and think about what you need to do and how you need to know how to do stuff. So hopefully those are helpful. Wait another maybe 30 seconds, and then I'm going to go to the green one. You can always screen capture. Do you guys know how to screen capture on your Chromebooks? Control and that rectangle button up at the top in the center. You do that, it'll screen capture your whole screen. And I am making a video, so I'll post the video and the assignment too, so you can always go back to it. All right, let's go to slide 5, number 4. Step number 1 says find the total interior angle sum. So what formula do I use for the total interior angle sum? And anybody? I know some of you are saying it silently in your heads, or maybe even out loud without your mics on. And what? N minus 2 times 180? Hopefully we said that. So what's the total angle measure for a hexagon? 720, absolutely. So we'll use the 6 because it's a 6-sided shape. So our total angle measure is 720, right? So then we've got to subtract out what we know. So we're going to subtract out all the angles that are given to us. So what angles are given to us? So I've got 150 for X. Is there another one that's congruent to X? Y. Yeah, those are congruent marks. So I've got X and Y that I can subtract out. And then I think you said Z. What does that little box mean? It is for sure 90 degrees. Do we have another one that's 90 degrees?
Yeah.
W. I heard that from multiple places. That's fantastic. So when you do that, what do you get? 720 minus 150 minus 150 minus 90 minus 90. Sweet. Your calculator skills are fantastic. So what that means is these two angles equal 240 degrees. There's 240 degrees left to share among those two things. And because we've got these congruent marks, right, those double loops here, we know that U and V are congruent. So U is congruent to V. So that's why we can just divide the remaining things by 2. So what's 240 divided by 2 is going to be 120. You are for sure correct. Does that make sense? We're going to start with the total, subtract out everything we know, and then divide up the remaining stuff among whatever's left. So in this case, we started with 720. We subtracted out the 4 angles that we knew, and that took a little bit of thinking. And then we divide what's left over by 2 because U and V share that 240. It's like I go shopping with my daughter with $240 and she gets 120 and I get 120. Somehow it never works out quite that way, but you know what I mean. Yeah. The Z and the W were 90. So we're talking about angles here. So because these guys had right angle boxes, we knew they were 90 degrees. I just kind of colored over them. It was hard to see. I'm glad you asked that. It is. So every hexagon, right? It doesn't matter if it's regular or not. If I add up all of those corners, it's going to be 720 degrees because I can use this formula right here. The total interior angle sum is always going to be n minus 2 times 180. And in this case, that n is 6. So 6 minus 2 times 180 is going to give me 720. And it just takes practice. So I'm glad you're asking the questions. This is fantastic. I don't want to rush, but do we want to move on to number 5? I'm looking at the chat. Let me know. Don't feel shy if you need more time. Okay. Number 5, there's no picture. What the heck? What kind of picture can I draw? What is this supposed to be? What do I know? A regular polygon. So, and I'm looking for an interior angle of that regular polygon. So I'm going to draw the interior angle because I know that's 160. I'm going to make it obtuse and I'm going to label it interior. So is it pretty easy to get the exterior angle from the interior angle? How are they related? So that's like when we put the trash back on our paper, on our picture, right? So if I put, let me find my right shape. If I have my octagon, I've got too many shapes here now. If I have my octagon and I put this back on, the interior and the exterior match up, right? So they should add up to what? They should add up to 180. So if I know the interior angle is 160, what's the exterior angle going to be? The interior angle is 160. What's the exterior angle? 20. Absolutely. So remember our interior and our exterior angles, they always added up to 180. They make a straight line. Interior and exterior always supplementary. So if I come back here, this is going to be 20 because they make a straight line. And then what was the total exterior angle of every shape? The central and the exterior angles always added up to what as a total? Because they make a circle. 360? That's the total exterior angle. So if I've got them cut into 20-degree pieces, 360 divided by 20 is what? What's 360 divided by 20? 18. That means there's 18 sides. So we have kind of another formula over here, and it's in our chart, so I'll show you this again. But 360 divided by the exterior angle gives you the number of sides, just like 360 divided by the number of sides gives you the exterior angle. So we did that in the chart. I'm going to go away from this slide, but I'll come back to it. 360 divided by n gave us that exterior angle. So just like in trig, where we could flip the things if the variable was in the denominator, 360 divided by the exterior angle is going to give you the number of sides. So you can kind of switch these things around. 360 divided by n gives you the exterior angle, and 360 divided by the exterior angle gives you the number of sides. So that's what we did here. 360 divided by the exterior angle gives you the number of sides. So my final answer here is going to be 18. Hardest part about this problem is that they just don't give you a lot of information. They don't give you very many clues. We've got 2 more minutes in class. Do you think we can do one more problem? Okay. Number 7. So if I want to find the number of sides, this is the exact same question. It's just a little bit easier because we have a picture. In the last problem, we used the interior angle to find the exterior angle. So what is the exterior angle here? If they're supplementary, they make a straight line. They're going to add up to 180. So if I know 45, if the interior is 135, then the exterior is 45. And then what did we divide by that exterior angle to give us the number of sides? All the exterior angles always add up to be, what's that magic number in the numerator? Somebody say 360? 360 divided by the exterior angle gives us the number of sides. So if the exterior angle is that 45 degrees that Theodore said, 360 divided by 45 gives me how many sides? And a lot of people, some people, I shouldn't say a lot, some people can just see this and they won't even need to do the math. So if you're one of those people, you should be able to see 1, 2, 3, 4, 5, 6, 7, 8. Or 360 divided by 45 is 8. There's a handful more of these. What I'd like to do is have you finish this and try one attempt of the homework tonight. So finish these slides. There's like 4 or 5 more. Some of them get kind of weird. And then try the homework. Do one attempt of the homework. And then we'll talk about it all tomorrow. Okay? Class is over. I'm glad you guys were talking more today. That's what I wanted. I'll see ya.